For this problem, we're asked to find a sinusoidal model that has a maximum of 172, 15.27 and a minimum of 355, 9.07. So a sinusoidal model means either a sine or a cosine, one of these cyclical periodic functions. So let's draw ourselves a rough sketch of what's going on here and see if that helps to motivate us about what kind of model we're going to try to create. So we want it to have a maximum of 172, 15.27. So let me just put a dot out here somewhere, and I will call this then 172, and this one 15.27. And that's supposed to be a maximum, and then it's supposed to go down to a minimum, and that minimum is supposed to be located at 355, 9.07. So let me put a 355 here and a 9.07 here. Okay, so those 2 points are supposed to be the maximum and the minimum of this sinusoid. So just given that information, the model we probably want to create is going to be one that comes like this and then cycles back up. Because notice that's going to hit the maximum and the minimum in the right places, and then we'll oscillate between those two. So just by that rough sketch, it looks like our motivation is going to be to create a cosine graph, because that looks a lot like the parent function of a cosine. So the first step is I'm going to start off and say I'm going to let our model be y equals some kind of cosine graph. Okay, second step is that this model has been vertically shifted and horizontally shifted. Probably the clearest one to see is the phase shift, which looks like it's, so since the maximum is at 172, it's been shifted to the right 172 units. So I will take out and go with x minus 172. That creates that horizontal shift. Okay, next let's look at it and try to figure out what let's do amplitude next. So amplitude would be half of the distance between the maximum and the minimum. So I can see that the maximum and the minimum are 15.27 and 9.07 respectively. So the distance between those would be 15.27 minus 9.07, and that's going to be 15.27 minus 9.07 is 6.2. So that's the whole distance from top to bottom. So I'm going to divide that by 2 to get 3.1, and that's going to be our amplitude, because amplitude is half the distance from the top to the bottom. Right, from the middle line it tells me how high and how low I go. In fact, I just mentioned middle line, so let's see if we can figure out where that middle line is. The middle line is going to be halfway between 15.27 and 9.07. So how do we get halfway in between two numbers? Well, that would be the average. So 15.27 plus 9.07 over 2. 15.27 plus 9.07. And if I divide that by 2, I get 12.17. So that's going to be my vertical shift, because that puts me up to the middle line, plus 12.17. Now there's only one piece left I have to do. I have to figure out what the period is. So for that, since the distance from the max to the min is half of the model, let's go 355 minus 172. 355 minus 172 is equal to 355 minus 172 is 183. That's half the model. So if I double that, 183 times 2 is 366. So to figure out the b, do 2 pi over 366. Get a little bit of reduction in there, I guess. Maybe pi over 183. And so that last piece will be pi over 183. So this would be a sinusoidal model. You can test it out. Its max is going to occur here, its minimum is going to occur here, and then you can use that to be able to predict other values of the function.